Okay, so multiple choice, part one, number three. The diagram shows four dipoles, 1 through 4, in a uniform electric field. For the diagram shown, which dipole will have the smallest magnitude dipole moment? Which dipole will have a dipole moment aligned with the field? And which dipole moment will have a counterclockwise torque? So the things to think about in this problem is that the magnitude, the magnitude of dipole moment, which is lowercase p, is equal to charge, basically the charge of the positive part of the dipole, times the distance between the two charges in the dipole. So that's one thing to keep in mind. That's going to help you figure out this one. The dipole moment is the same direction as the E field. So this might be really confusing because the direction of the dipole, the way that it points, is towards the positive charge. And the reason I say it's confusing because in chemistry, whenever we draw dipole moments, we always point it towards the net dipole towards the negative charge, where the electrons are. But in this case, P points towards the positive charge. So that'll help you with this. And then number 3, counterclockwise torque. So that one we'll have to take a look at the forces acting on each charge. Note that the axis of rotation for each of these is in the middle here. And I'll draw dots, is in the middle. That's where the axis of rotation is going to be for each of these dipole moments. And so what we'll have to figure out are the forces acting on each dipole and see which way that they would move. And so if we take a look, let's look at the smallest dipole moment. So we know that the dipole moment is equal to the positive charge times the distance between the two. So for 1, P would equal Q times the distance, which is D. For 2, we would have the dipole moment is equal to the charge, which is Q, times 2 the distance, which is 2D. For number 3, we'd have the dipole moment is equal to the charge, which is 2Q, times the distance, D. And then for the last one, same thing. The dipole moment is equal to the charge times the distance between the charges, which is 2D. So if we take a look, which one has the smallest magnitude? This has a 2, 2, 2. This is a 1. This is the smallest. So number 1 is the smallest dipole moment. Number 1 is the smallest dipole moment. Now, dipole moment in the same direction as the E field. We know the E field is uniformly moving in that direction. So, the dipole moment, the direction of this dipole moment is, remember, it's always towards the positive charge, so it's pointing up. This is not in the same direction. Here, oh, I forgot to write the negative charge here. Oops, there we go. Here, the dipole moment points towards the positive charge again, which is, oops, wrong color, which is this way. Not aligned with the electric field. Here, the dipole moment points again towards the positive charge. This arrow is pointing the same as that one. Therefore, the dipole moment in the same direction as E field is number 3. Now, figuring out the counterclockwise torque, for this one, we have to look at the forces on each charge. And so, for example, if we take a look at the force that's going to act on, let's say, for this dipole on this positive charge, this positive charge, if the electric field is pointing this way, the force is going to point in that direction. So essentially, this dipole would move in that direction. Sorry, this charge would move in that direction, to the right. So if we have the electric field, now, maybe I should draw this separately. Yeah, so I'm going to erase this part. That way I can kind of better explain these two right here. It's one of these two. I'll let you know. It's not the other two. But, or at least these are good examples. Okay, so if we have an electric field off in this direction, right? Off in that direction. We can think about it that this electric field, remember that electric fields start on positive charges. So it could be that there's a positive source charge here. But we also know with electric fields that they end on negative charges. So we could have a negative charge there. We don't know, though. We don't know what's producing the electric field. We have no idea what's producing the electric field. But just by thinking about it, we can understand there's an electric field going this direction. Therefore, it's either being created by a positive charge here, because we know that electric fields point away from electric charges, or the electric field is being created by this negative charge, because we know that electric fields point towards negative charges. So it could be either one of these options. So let's say we place number 1 in this electric field. So here's number 1. Number 1 is a positive Q. Let's put the dipole for number 1 negative. Well, we know the force based on this electric field is going to push this positive charge. Remember, the axis of rotation is right here, is in the middle here of this dipole. So we know, due to this, the force due to the electric field is going to push this charge to the right. But the electric field will push this charge to the left. And if you look at the way that, if this is the axis of rotation, it's going to spin this way. It's going to spin clockwise. Right? It's spinning this way, which is clockwise. Now, that's for number 1. This is number 1. Well, let's look at number 4. What does number 4 look like? So number 4 is the opposite. It's a negative charge there and a positive charge down here. So now, if we look at the forces acting on this, on the dipole due to the electric field, notice the force acting on this charge will be towards the left. the forces acting on this part of the dipole, remember this is dipole number 4, by the way, will move towards the right. And another way to think about it is we know that charges produce electric fields. And so if you even just look at the charges, these are opposite, therefore they attract. So the force will be this way. Here, the charges are the same, therefore they'll repel. So the force will be in the other direction. So if you notice, if this is the axis of rotation of the dipole, it's going to spin counterclockwise. It'll spin in that direction due to the electric field. Therefore, that is number 4. All right, long video, I know. Hopefully that helped for number 3. Cool.